Right, starting. So let's begin. Okay, cool. So tonight, going to look at study unit 8 again. So we did it Sunday, but doing a recap tonight. Then on Thursday, we will do study unit 9 with a recap on Sunday again on study on chapter 9. So tonight confidence interval, and then on Thursday and Sunday we will do hypothesis testing. And so just again that we get enough exercise in with some of the exercises and with some of the other information. Okay, so just to recap again on what we're going to look at. So again, quite important in this chapter is nearly the continuation of what we did in chapter 6 and 7. So with confidence interval, we will again look at Z values. We look at the formula that goes with a confidence interval. What is important in this instance is that we basically will sit with a scenario where we will always need to decide. There will be 3 options of confidence intervals. The easier one is always the proportion, because that one can directly see, and you will see from the questions as well. Mostly they say proportion, but you will also see in the information that they share with you in the question. Very, very easy to identify the proportion question versus the other 2. Okay, so the other 2 is around the confidence interval when we need to estimate for the mean. And in this instance, it can happen when we know what the standard deviation is. If we know what the standard deviation is, we will use a Z. Then very simple, as in proportion, we will use a Z. Z, we know from study unit 6 what to do with a Z. If the standard deviation is unknown, we will work with a t value. Okay, and then when we work with a t value, what then becomes important is things like the degrees of freedom, and then that significance level that they will share with us. But the formula for that is when this significance level divided by 2. So I will show you the formula of the T as well. Degrees of freedom for T is n minus 1. So we will get the sample size. They need to tell us the sample size, or they can tell you degrees of freedom, but that nearly gives it away that you need to work with the T. So they will give us a sample size, and we must just remember to subtract 1. Also important is, and I will show you when we look at some of the options, that if you don't subtract with 1, there is normally an option with your answer. If you confuse the T with a Z, there is normally an answer for you as well. Okay, so basically the importance of this chapter is that we're going to look at confidence interval estimates. We're going to look at confidence interval estimates for the mean, where the standard deviation is known, when it's a Z. Standard deviation is unknown, then it is a T. And for the confidence interval around the proportion, we will always use a Z. Okay, then what I also want to show you, and this also comes from study unit 7. So what we are doing with confidence interval is you've got a mean. So if it's the population mean or if it is the sample mean, you basically got a mean and you want to around that mean that sits, let's put it like this, that sits in the middle. We just want to say what is the confidence around it. So we've got a population, and we are taking a sample of that population, and we just want to say, okay, that population mean is, say, 50. We're happy to say that when we draw the sample, that sample maybe sit between 45 and 55. Okay, so that is basically what a confidence interval does. So it looks at your data. So if you have a population data, you draw a sample of that population data. There is a bit of error in it because you're not dealing with the whole population. So what that does is it basically builds two intervals around that middle point, the mean. What is happening with this is, so we've got the mean, then we're going to tell us how big we are working with. So a confidence interval of 90% or a confidence interval of 95% or confidence level of 99, 95, and 90. That's the three that will be tested in the exam. They might give something different in an assignment to see if you can get to it via the tables, but most likely not. And in the exam, it's always 90, 95, and 99. Okay, so this table is also in your study guide, but again, it's nice to have it with the information that when we're going to use it, we have it. Then the other thing that we'll see, so we're going to use the Z, and then in each of the confidence intervals, remember from study unit 7, that was the standard error. And so if we look at the sample, the same in this formula, we're going to multiply by the standard error, and the same when we get later on to the proportion one. Look at that in the formula of a proportion. Again, we are looking at the standard error. Okay, so just things that are very similar to what we have done in some of the previous study units, so that we can just nearly, when we see it, just nearly try to make the connections again with some of the previous study units. Just quickly want to go there. Okay. So basically, confidence interval, you look at the mean and you're building lower confidence to the one side. In this instance, the lower confidence would have been 45, and the higher confidence level would have been 55, with the mean in the middle of that. Okay, so let's look at the first question, and let's look at what they ask. Identify if it's a Z or T that we're going to use, and then going to look at the formula and work further from that. So a statistics practitioner took a random sample of 50, so we know N is 50 from a population with standard deviation of 25. So population standard deviation, that tells me that I know what the standard deviation is. So the standard deviation is known. So because it is known, I am going to use the Z. Okay, so that's nearly the first thing that is important for me to get out of the question is population standard deviation is known. Because it's known, I can use the Z. And so let's just again look at what that formula then is. It's the mean. We'll get those things now to replace. So it is Z times the standard error. Okay. Before I even go to the mean and what the other things are, let's look at the Z. So now that we know it is a Z, they tell me we're working with a 95% confidence interval. Let me just draw it better, that the 9 can still be there. So we're working with a 95. So if we're working with 95, the 95 level tells me that your Z is 1,96. For confidence intervals, we are always going to use the two-tail. Confidence intervals always two-tail because there's always a lower limit and always an upper limit. They might not ask you every time to give both, but because it's a confidence interval, it nearly with what the word says, interval, so there needs to be a lower end, there needs to be a higher end with the middle in the middle. So 95%, we can always say then the Z of 95 is 1,96. Okay, so you don't need now to go to the Z table or anything like that to prove it. We know now it is 1,96. Okay, so now we can complete the rest. So let's see, they said sample of 50. They told us the standard deviation was 25. And they told us the sample mean is 100. And it's just okay. So now a few things also to guide you guys with. So we know the mean is 100. So the point in the middle is going to be 100. The upper confidence is going to be more than 100. The lower confidence is going to be less than 100. Okay, so when I look at answers, I look at this one and say, okay, 93 less than 100, yes. 106 more than 100, yes. Okay, so that might be one of the answers. Okay, so this cannot be. We can't have the lower limit unless we don't have this standard deviation. So option 2 can't be. Option 3, well, also doesn't look like it, so probably made a mistake here, or they want you to make the mistake. So there can't be 100 between 9 and 10, so that is also not the option. Can there be 100 between 94 and 105? Yes, that can be between 100 or 59 and 106. Yes, probably not, because it looks very much out of sync. But for now, let's just say it might be an option. Okay, so then we work it out. So it is 100, and again, my calculator is not, I've got the HP, so it's not as nice as some of the others. So I first need to do bits and pieces of this. So I first need to work out what is the square root of 50. So that's 7,07. So 25 divided by 7,07. So we get 1,96 times 3,5355. So if I multiply the 3.5355 times 1,96, get 6.9296. Okay, so interesting. It was part of one of the options, but not what. Okay, so in that option 2, they nearly gave me the formula that I'm working with. Quite interesting. So 100 plus 6.9296 will give me 106, and they round it off to 2 decimals, so 0.93. Okay, that one is close. Not there. One could see that there was a decimal mistake. And then 100 minus 6,93 gives us 93,07 or 0.7. And so that is basically how we will work this problem out. So first, I think the important thing is that we identify that it is population that we're working with. So we know that what the standard deviation is. Because we know what the standard deviation is, we can work with a Z. Then, because we know we're working with a Z, the 95% confidence interval, we can automatically say that is 1,96. Then we just follow the rule or the formula for the rest of the question to work out what the confidence interval will be. Okay, so somewhere we'll get the one that is unknown, so we will see how that is phrased as well, so that you can just see the differences in all the ways that they can ask it. But critical, they need to tell you that it is a population standard deviation that we're working with. Else we will assume we're working with a sample. Okay, so let's look at the next question. Okay, so they tell us it is known that the ages are normally distributed with a mean of that. We've got the mean. And the sample standard deviation. Sample standard deviation means that the standard deviation is unknown. Even though we have a number for it, it is not a population standard deviation. So the population standard deviation is unknown. Because it is unknown, we now work with a t. Okay, so then it becomes slightly different. So when we're working with a t, we need to get two things. We need to get the degrees of freedom, and then we need to work with the alpha divided by 2. Okay, degrees of freedom, it's n minus 1. So let's see. It is known that the ages are normally distributed. Sample standard deviation of 15.05 with a random sample of 8 men. Okay, so that really becomes small. So 8 minus 1, the degrees of freedom is 7. How we get to the alpha, it is 1 minus the confidence interval, which is 1 minus 0.95, and that then divided by 2. So 1 minus 0.95 is 0.05. So the alpha is 0.05 divided by 2, which is equal to 0.025. Just excuse me, I just quickly want to get some water. Sorry about that. Okay, so we've got degrees of freedom of 7, and we've got the significance level that we gonna check. So let's go to the T table. Let me just quickly open that. So I'm using the one that you guys got. So as part of study letter 101, if I need to share it on the WhatsApp group, let me know, then I will share it so that we all work with the same table. This is also what you guys can use in the assignments and in the exam. Okay, so key table. So we said that we're working with degrees of freedom of 7 and 0.025 degrees of 7. So let's just zoom in a bit. Okay, degree 7. Zero comma 025. So we're setting with 2,3646. Sure. Which has 2,3646. I was hoping it's somewhere here, but not. So let's complete for others as well. 43,75 plus minus 2,3646 times, and remember, standard deviation divided by n. It is for samples, so it's fine. We multiply by 15.05, and for sample was 8. I will move this out a bit that we okay. So we use that formula that is part of where standard deviation is unknown. So it's still the mean plus minus the t that we've worked out times the standard error. So in this instance, we just use the sample standard deviation as they've given it to us. So again, it will be, let me use my calculator. So square root of 8, I get 2,8284, so 15.05 divided by that. So I get 43.75 plus minus 2,3646 times 5,321. So that was my answer out of that calculation. So hopefully that is correct. So 5.321 times 2.3646 gives us 12.582. Okay, so again, if you look at that first answer, they nearly given us the mean plus what we needed to plus and minus. This was previous papers that was pre-COVID, so I don't think they do this anymore, but it will be again interesting to check when you get your mock assignment and things like that. The other thing, again, just quickly, the mean was 43,75. So let's just check. Yes, it can fall into those two. Yes, it can. Okay, no, it can't. Yes, it can. So there is 3 options. So 43.75 minus 12,582. That gives me 31,168. Sure. Okay, 31,168. Yeah. Okay, so 13. Sheesh. Okay, so if you swap the two around. I nearly wanted to ask now what's the difference between the two. Okay, so 31 is fine. So if we add the two to get the top end, it will be 56.33. And again, because I rounded off those two, it's not 100% rounded to that. But let's quickly just make 100% sure. 0.582. So 56.332. So very close to that. But obviously, if I didn't round that off, we would have gotten the answer. And again, so there they swapped the 3 and 1 around, and here again they swapped the 6 and the 5 around. So very easily one can actually make that mistake if you quickly look for the 3.16. So very easily one can make this mistake of looking at the numbers and you're nearly seeing a 5 and a 6, so you want to say that is correct. Okay, so option 2 is the correct one. I just want to check if we used the 95% as a Z. I just want to see if they actually have the option for us. So then it would have been 1,96 instead of 2.3646. I just want to, for interest's sake, check then if we used the Z, it would have been that as instead of the 12. So then it would have given us, option 5. So if we use the Z and said, okay, but the standard deviation is known, we used the Z as 1,96, option 5 would have been the answer that you would have picked. Okay, so again, nearly very important that even if we do the wrong thing, there is an answer for you to pick. So in the assignments, you guys will also see that sometimes you get 1 out of 2 points. So what might happen is in assignment 4, if you've done this, but you used the Z instead of the T, you maybe get 1 point if you've chosen option 5. Okay, so that is sometimes how you would have seen in some of your marking. Sometimes you get 1 out of 2. So that might be one of the ways that they can give you 1 point because you at least followed the right process, but you don't get the full marks because you didn't use the right formula or something like that. Okay, so we've done one with the Z, we've done one with the T. So let's see what else is there. Okay, so a few definition type questions around the estimation of the mean. So let's look at what they tell us. The random sample of 25 people was drawn from a population. The sample mean and sample standard deviation are 510 and 125 respectively. Okay. Sample standard deviation tells me that my population standard deviation is unknown. Okay, if I know that, it tells me we're going to work with a t. So even just out of that, so then they tell us when calculating a confidence interval of a population mean, the t-test should be used because, okay, population standard deviation is known. No. Population mean is known. No. The sample standard deviation is known. No. The population standard deviation is unknown. Yes, because that is why we will go for it. The sample size is small regardless of the population standard deviation. And that is no. Okay, so yes, there is in your textbook, it says that for small sample sizes, we will use the t, but it is more to do with the population standard deviation than with a sample size. Okay, so we can work with a small sample size if we know what the standard deviation of a population is. Then a small sample size is not the biggest problem. The biggest problem is if we don't know what the population standard deviation is. So they might also try to catch you in a question to say it is a small sample, like here, and then they might tell you that you have a population standard deviation. So then population standard deviation tells me I can work with a Z. Okay, so just be very careful with this one specifically. It is more to do about the standard deviation than it is about the sample size. Okay, let's first do the another one about theory, and then we can do this one. So let's look. The principal purpose of a 95% confidence interval for a mean is, okay, so let's to estimate a sample mean. Okay, so let's see, we've got the sample mean. So we want to estimate around that sample mean what the population mean will be. So it's not to estimate the sample mean, because we have the sample mean. We will always have the sample mean. To test a hypothesis about the sample mean, no. Hypothesis testing we will get to in the next chapter, but it does not link to a confidence interval. So hypothesis testing is to tell us if something is similar or not similar to a sample mean. That is not what confidence interval does. So it's not that. To test, to estimate a population mean, that is correct. So it estimates a population mean. To provide an interval that covers 95% of the individual values of the population. Okay, so just look at at that statement nearly. So if I've got, and let's say, if we look back at the elections, out of how many 22 million people that are registered, they did samples about who's going to win. So then they selected 1,000 or 2,000 people. So, and they could say, well, with a confidence interval of how much this is what we say is going to happen, that sample of 2,000 people definitely did not cover 95% of individuals. Okay, so just be very careful again how they phrase it. So what 95% confidence interval in layman's terms mean is that I've got a 95% probability that the population mean will fall into this area between the lower confidence limit and the upper confidence limit. So that is basically what the confidence interval means. It tells me that with 95% confidence, with 95% probability, that population mean will lie between those two values. Okay, what that population mean is, we don't know. We just know that it, with confidence of 95%, it will lie between those 2 points. Then just read again, the principal purpose of a 95 confidence interval for a mean is to estimate a population proportion. No, but if it was the principal purpose of a 95% confidence interval for a proportion, which is the third one that we will deal with, then it would have been right to say we're gonna estimate a population proportion. So again, for the mean, we'll get the sample mean. With 95% confidence, we can say that the population mean will fall into those brackets. The same with the proportion. We're going to get a sample proportion. Then with 95% confidence, we can say that the population proportion will fall within the lower and the upper limits. Okay, so that nearly is what confidence interval is in a nutshell. It is a 90, 95 or 99% probability that the population mean will fall into certain brackets. Okay, let's then look at another one. So we've got a sample of 30, probably small, but still fine, have been collected from a population for which it is known that the population standard deviation is that. Okay, known, work with a Z. We see 95% confidence interval. So because it's a Z, 95% confidence interval tells me the Z value will be 1,96. Okay, so then, like we did in the first question, the Z times the standard error. And let's just see what we have. The sample mean is 240. So let's again check 240. Okay, that might be 240 and that, so no, that will most likely be what we're dealing with there, but let's not just fall for it, because the other one also had it when we were working with the other one, with a T, so it might be that they give you a number that might be the T as well, so can't always assume it will be that. Sure, very close to that one. So that can be another one close to that. So 240 in the middle, and then this one feels like it's swapped around. That feels like the upper, that's the lower, so we can't have that. Okay, so then let's work out what we're gonna subtract and add. So it's a 1,96 times the standard deviation is 10. The sample is 30. So let's see what we're gonna plus or minus with. So 10 divided by 30, the square root of 30. Again, I made a mistake. And that gives me 1,8257 times 1,96. So 240 plus minus 3,5785, which was actually that one that we can work with. So the top will be 243,5785, and the bottom one will be 236.4251. Okay, let me just check that again. Sorry, not 51. And how easy it is to make those mistakes. It is 2364215. And again, like you guys would have seen now, is that is just nearly switched around. So again, very easy to make that mistake. Those two very similar nearly, and the same with this one. So very easy to make a mistake by just reading it the other way around. So normally not how they would do it. So just be careful when you get these assignments as well, that if there are two or three that is close resemblance, that just check what the order of the numbers is. But again, they've nearly moved away a bit from how it was pre-COVID and now. So mostly what they will test for is the Z and the T values, and it might be that they test around a Z that was 1,96, and not something like the other one that you might use for 1,645. Okay, so that might be more the things that they will test with nowadays, instead of testing if you write the number in the right order. Okay. So then the last component of study unit 8 is the proportion component. So once again, we've done the estimation of a mean when the population standard deviation is known, which is a Z. We've done where it's unknown, which is a T. And then when we go to proportion, it is always a Z. Okay, so proportion can be a small sample. It really does not matter. So again, if they want to trick you by saying you're working with a small sample in the proportion, just remember that proportion is always a Z. Okay, so we will always work with a Z in proportion. We don't have a T when we're working with proportion. So that is very important. So even if it is small sample sizes with a proportion, we are working with a Z. Okay, so let's see what they have asked us. So a random sample of 80 observation results in 50 successes. The 95% confidence interval for the population proportion. Full population proportion, we know it's a Z. 95%, we know that Z is 1,96. And we're working with the successes. So the successes is the 50. So we can say the successes is the 50 over 80. So let's again quickly look. 50 divided by 80 is 0.6250. Okay, so now the same principle we can nearly follow that we did with the mean. Let's quickly check. 0.625. Okay, so again, that is probably a component that we will add to the plus and minus, but already that should be in the middle. It's not, so we can eliminate that. Is that in the middle? It might be. Is that in the middle? 6 to, sure, so 6 to 5 can be in the middle there. So might be, can be in the middle there, so it might be. And again, this seems like it is swapped around, so 6 to 5. And that is even wrong, so definitely not option 5. Okay, so we sitting with 3 possible options that we go with, but let's work it out. So the Z 1,96, and then multiply by the standard error. So the standard error that we also did in study unit 7. So the 0.625 plus 1 minus 0.625. And that divided by the sample, which is 80. Okay, so let me just, on my side again, with my calculator, I'm first going to do 0.375 times 0.625. That gives me 0.2344. I divide that by 80. I get 0.0029. And if I take the square root of that, I get 0. 0541. Sorry, let me just. So 1,96 times that. So I get plus minus, as we all thought, 0,1061. So if we then do that calculation of 0,625 plus 0.1061, I get the top end 0,731. Is that, and at the bottom end I get 0,519. Okay, which is that one also. So it is option 5. Sorry, option 4. So again, option 5, they messed it up a bit. So instead of 519, they made it 591. And the same with 0731, they changed it up again. So again, just when you read it, be careful, but we have eliminated option 5 actually, because you can't have a upper confidence limit that is smaller than the lower confidence. So that is in any case wrong from the start. Okay, so let's go to the last question for tonight. So again, let's just see what we're saying. According to statistics report on Stats SA, the surprising number of motor vehicles are not covered by insurance. The result consistent with Stats SA report showed that 46 of 200 vehicles were not covered by insurance. Then work out the 90%, 95% confidence interval estimate for the population proportion. Okay, population proportion, as we now know, it's a Z. 95% is 1,96. I assume they want us to work out the vehicles that are not covered. So the 46 over 200. So let's quickly see. 46 divided by 200 is 0,23. So again, when we start with a mean or the proportion that is 0,23, we can see that one is going to be wrong again, because it should be smaller than 0,23, should be more than 0,23. That's wrong. 0,23 on its own, also not right, because that means that we actually have no standard error, but then that would also be the same. So again, wrong. I assume that should have been like that. Again, smaller or bigger, smaller, that again can't be. And this one is possible. So actually 2 options left. So just by working out that proportion, if this was an exam and you did not know anything further how to work it out, you had 2 options to guess between and not 5. Okay, so just by working out that proportion, you already actually can eliminate 3 of the options. Okay, so let's just check if we multiply by the standard error. What do we get? Because again, it is still between 2 options. So 0.23 times 0.77, and that divided by 200, and square root of it. So that is what I would work out. So 1.96 times that will probably, oh, there wasn't, is 0.0583. So 0.23 plus minus that. So the top one is 0.2883 I get. Again, I rounded that off, but 0.288, 0.288. So that is the top one, and the bottom one is 0.17. So again, because I rounded that off, mine would be 1717. So 1716 is close enough. So you can see option 4 was just swapping the 2 around. So the right numbers, but again, option 4, you can't have the smaller one as your upper limit and the bigger one as your lower limit. So that is why that one was definitely wrong. So option 5, they might have, I look at those 2, might have used something different in, and it might have been that they actually have used 1.645 when they worked that out. Okay, but the right answer is option 1. Okay, so that is it from chapter 8. So basically, just quickly a recap. So we look at the interval estimates. So we've got interval estimates for the mean. When the standard deviation is known, we work with a Z. When the standard deviation is unknown, we work with a T. Then the third one basically is the confidence interval for proportion. And for proportion, we will always work with a Z. So then if we look at the formulas, what it normally is, and Zolani, I'll be with you now, is that you sit with the mean or proportion, then plus minus the thing that you add or subtract is your Z or your T plus your standard error. Yes, question.
Hi, Jinmin. I just want to find out if you possibly will have a document that contains all this theory of this each unit, study unit, so that maybe during the exam it will be available, just to make sure that we are able to tackle those theory questions. Yes.
Let me, I have something. I will share that with you.
Right,
I will definitely share that with you. I've got the theory PDF that I will share.
All right, thanks, man.
Cool, no problem at all. Yes, there's another hand.
Hi, Jean. I just wanted to find out from you with regards to the table, that table for the T distribution.
Yes.
The alpha, it's only a few numbers that we have available for the alpha. Are we going to get a question that we need to work out
No.
something that is not there?
No, and you can basically see there's for 90%, there's for 95, and there's for 99. And the ones that you guys will work with is then the one that is divided by 2. So you will always work with the other one. So no, that is what you will work with. You don't need to worry about
Okay.
so
The in-between values maybe. Or...
You don't need to worry about that. Saying that in the assignment, again, what they might ask you is, but they can't ask you in the assignment now to suddenly do a 0.96 and you need to get a 0.04, or so. All that they can do in the assignment is that you need to work with one of these that we sometimes don't do. But also, let me quickly show you just the ones that we normally work with for the T. So if you have a 90%, it will be 1 minus the 90%, which is the 10% divided by 2, which will give you 0.05. When we have a 95%, it is the 5% divided by 2, which is 0, hope I'm now right with that. And then the 99% is 1% divided by 2, which is 0.005. So on that table, the ones that we work with, and let's quickly take away some of these. Just want to see. How I can do that. No. So let's just make it a new color. So the ones that we, not text, highlight it, there's for 0.05. Color. Cool, so that's a 0.05. So that's the one that we know. The other one was 0, sorry, that, yeah, 0.05. That was the one I just did, 0.05. Then 0.025. You can see again that was, let's just delete all of this. And then the last one was 0.05. Okay, so they might say to you, you work with, let's quickly look at the 80% confidence interval. So that will be 1 minus the 0.8 over 2. So that is 0.2 over 2, which is 0.1. 0.1, we've got a value for. Okay, so that is what they can do. But they can't now have that you somehow need to know what is a 0.08 number. Nobody knows. But they can have it that you can go to this level that is in the table. Okay, but that's the only place where they can go. So I know in a previous assignment way ago, they used a 0.98. So the 0.98 would have given you 1 minus 0.98 would have given you 0.02. If you divided that by 2, it would have given you 0.01. And there is a 0.01. So that is the only things that they can do for you to use the t-table. Nothing in between these values. That is just will not happen. But it might be that instead of the ones in orange that we always use, they might go to the ones in red. So to get to the 0.25, and again, will probably not happen, but to get to the 0.25, it would have been, what is that, 0.5. So because 0.5 divided by 2 would give us 0.25 as that one. But to be honest, I have only seen ones that they do a 98 and not a 99 or 95 and 90, but then you could still use the Z table. Okay. Long story short, it will only be the ones that are on the T table that you need to worry about. Cool. I'll get the theory. I know I've got a PDF on that. I'll share that with you so that you have it. I will also check. I know I've got one for hypothesis testing, so I will share that as well, so that we have that for the next session that we will have on Thursday. So Thursday we will do, and let me stop the recording. On Thursday we will do study unit 9. Then on Sunday at 9 o'clock, we'll do a recap of study unit 9. And then next week, on Tuesday and Thursday, we will do the prep. I think we a bit ahead this time, but then at least we can do more prep for some of the other study units that we went through very quickly, but also we can, after we've done everything, we will look at all your assignments and just work through that as well. Okay, that is it for tonight, everyone. Hope it makes a bit more sense than a week ago. And then we will see on Thursday again. I will share everything on WhatsApp, links and the presentations and the PDF documents as well, that you guys have it. Okay, have a good evening. Stay warm. Stay away from the rain. It seems like it, touch wood, have stopped for now. But keep warm, everyone. I know it is cold everywhere. Just keep warm. Cheers, and see you on Thursday again. Cheers,
Thank you,
everyone.
Jean. Bye.
Thank you. Bye bye.